convinced of our technology. Welcome to this special class today. We're really extremely glad that David Macaulay is so generous to share his time with us and to give a presentation and demonstration on how to draw to understand things. He really is the expert. You've seen his books in the Couch Lab already, so we're really delighted to have you here today. Thank you very much for coming.
Thank you. Can you all hear me? Is that good sound? Okay. The technology has been defeated, and we are victorious. Once again, I introduced myself in a couple of different ways. The main message this morning is that drawing is actually good for you. A lot of people are intimidated by the concept of drawing because they confuse it with art making. I'm not here to talk about art making. Art making is merely one little byproduct, if you will, of drawing. Drawing for me is a way of thinking, it's a way of learning, it's a way of seeing. It's a conversation between you and an object, between you and ideas. Sometimes it's the result of a conversation between you and someone else. I think that the most important use of drawing for this particular group is to sort of give you that added tool to force you to really confront the range of issues in front of you when you're working on a project. The only thing that will differentiate something you create from something someone else creates is the quality of the problem you were able to define in the first place. It's not about the solution, it's about the quality. I mean, it is in the end, but initially it's about how good the problem is. Have you been able to come up with a problem that really makes sense? And I find that in drawing, when I'm usually trying to explain something, I'm beginning to understand, first of all, what it is I'm trying to explain. I'm beginning to see through the drawing process what aspects of this thing really kind of make sense and which don't, which are more important, which are less important. And ultimately, it helps me sort of focus in on the finished object, which for me is a drawing. I suppose you could call it art. But for me, it's just, it happens to be the end product. For you, drawing will not be the end product, but it will be, I hope, perhaps, a way of getting you to an end product through a process that you've been able to kind of understand and, in a way, record through sketches and drawings and scribbles. None of this has to be beautiful, but it all has to be, it can all be ultimately somewhat useful. Drawing is a series of asking questions. When you sit in front of an apple, I mean, you may not think about it. You may think, I just have to record this shape on this piece of paper, but that's not the object. It's a bunch of questions. It's like, sort of, what is the exact shape of this thing? What's going on around the corner? What can't we see? What's happening inside? What can we learn from the surface about what's going on inside this apple or this whatever it is? This is sort of drawing from life, which is not a bad way to start, and it's a good way to sort of get exercise. But I want to start with a little project that will give you some sense of the range of drawings that I found myself using in order to basically produce one of what will be a series of books for young engineers who don't like to read. I don't know whether there are any here. I would have been in that category around the age of 6 or 7 or 26. I have a strong feeling for these things. So I'm going to move to I'm going to move to this, and I'm going to give you a very quick little read through. This is a reader. This is a reader for 6 or 7-year-old kids. But the subject matter of these readers is all nonfiction. And it's basically using drawing to try to suck someone in, some unsuspecting young mind, into this world of how things work, touching on their imaginations, their curiosity, and hopefully seducing them effectively enough so that they actually want to read the words that go with these pictures. So I don't want to show you, there's no need for me to show you all of them because you probably know how to read almost all these words. But you get the idea that you get lured into this thing. And this thing, as you have already recognized, is a very familiar object. It's an object so familiar that we completely take it for granted unless it stops working. And it's amazing how quickly we stop taking things for granted when they stop working. We're just used to it. We don't look at them. We don't see them. In the middle of the night, we hardly even touch them. But we know how to find it. We know how to use it. We know how to be done with it. So familiarity, in that sense, really does breed a kind of disdain for looking, for taking note of the things around us. We become so familiar, we stop asking questions. The best thing about drawing is it forces you to ask questions again about even the most familiar thing, which is why I mentioned the apple. So I take you through. I decided that I would introduce the toilet and the toilet system as part of a larger system that began with a human system with which it interconnects. Toilets are relatively useless without us. And there are those sort of fundamental issues and problems like no paper that confront everyone. But those are the little things, those are the little clues that remind us, this is very familiar, this is my world. And into the tank. Now, you may think for a 6-year-old or a 7-year-old kid who's not much of a reader, this is a little bit of a stretch. I hope it is. I hope it is a little bit of a stretch. So I'm scrambling around on my hands and knees around one of our toilets, trying to sort of watch the flush action, see exactly how the water disappears, and where it's coming out in force and where it's just kind of leaking out. And so that's what this is all about. I mean, a character is only a way of engaging the younger audience. The dog with the missing dog biscuit. A little bit of a... Anyway, if you need to know, if you have problems with your toilet tank and you're not quite sure what to do with it, you probably can all figure it out. But if you weren't able to figure it out, you just get this little reader. Might be a little embarrassing at first, but get it and you will know exactly what's supposed to happen. You will know what happens after the toilet with the septic system. If you happen to live in a place with a septic system, you will understand have a little bit of appreciation for the biochemistry going on here, the bacteria at work, and their job is, of course, crucial to making this whole thing work. It's what gives us green grass. If you live in a metropolis like Hanover, for instance, you might need a larger system. And I did spend a few days in August of 2 years ago now. It was hot as hell. It was like August afternoons at the waste treatment facility in Hanover. I don't recommend it unless you absolutely have to, but it was terrific because they actually let me hang around, which was an odd request, I suppose, to begin with. But they let me hang around there with my sketch pad and so on. And I finally figured out what all those different shaped tanks do. I mean, I've driven past waste treatment facilities for years. I've flown over them. But I never really understood what the round tanks, the square tanks, the covered tanks. So now, to help this young reader read, you can actually learn about aeration tanks and digesters. I mean, digesters, what a fantastic life for bacteria, to be flung against the walls endlessly in this stream of sewage. I mean, it's a spa for very tiny creatures, in a way. So anyway, that's what this is all about. That's how I introduce myself. That's the latest. But now I will jump to a range of examples that I hope you will find useful. I don't have a graduate degree. I just have this Encyclopedia of Science that I got when I was 10. And it's actually done reasonably well for me. It has information about everything I could ever want to know. At least that was the way it was sold. Empire State Building. SS United States, fastest steamship in the world. Won the Blue Ribbon, and then it got beaten out by airplanes. And so it remains in Philadelphia, tied up to a dock. It is the subject, in part, of my latest effort, and I will take you through a little bit of that, but I want to really try to emphasize the decisions I made about the drawings I did, or am doing. Nothing's finished yet. I haven't made a single piece of finished art for this book, which is due in about 2.5 months. So I'm in big trouble, but I do know that at least the material is making sense to me, and it's partly because of the drawing process. Just to prove that I really was there, that's me in the cap being blocked by this selfish woman who stood in front of me as the picture was being taken by the ship's photographer, my brother, my mother, my sister. And we were heading west. to the Empire State Building. The only thing I knew about the United States when my mother said we were going to America was the Empire State Building and cowboys and Indians, but that didn't really count. The Empire State Building is the thing that got my imagination, so I did want to give you a sense of the relationship between us in England, which is shown here upside down because I want you to move across the drawing from left to right, which is the logical way to move for many of us, not all of us, and end up in the West there. Okay, so last night on the ship, this is a 4-day journey. The last night of this 4-day journey is something called gala night. They have this fancy menu with food things you can't pronounce, at least not if you're from Lancashire and you're 10. And so there we are, having the times of our lives. We pull into New York, finally, after this. Now, I had no idea that this was such a fantastic ship, that it was really a work of art in terms of speed, carrying 2,000 people, more like 3,000 people, across the Atlantic in a 34 knots or something like that, and then finally to pull into up the Hudson and into Dock 86, Pier 86. And there's the Empire State Building to greet us. But wait a minute. I'm 10 years old. I know what the Empire State Building looks like. I know how big it is. It's this big. It's not this big. This is pathetic. What a disappointment. It was the first time in my life I felt actually cheated. And the irony is, I was cheated by an illustrator. But he got away with it. On legal grounds, he was okay, because you'll notice that the building doesn't actually touch the skyline. It floats above it with a sort of foggy mist, which means he is off the hook for misleading young readers who pay attention to the illustrations, even if they don't actually read the words, which was me. So what kind of information do I need to ultimately be able to tell my story? And it's what you would expect. It's plans. It's cross-sections. It's all this kind of stuff that basically means nothing to the average reader. And if I attempted to use this as the material with which to present this extraordinary creation, I wouldn't last long. This is a bulkhead. This is a watertight bulkhead. This is basically one of 20 walls built from side to side, from the base of the ship, from the bottom of the ship, up to about a deck, something like that, halfway up the height of the hull. Heavily reinforced. And this is the thing, like an ice cube tray, except an ice cube tray where the containers actually really touch the bottom, and there's nothing seeping through on either side. The whole point of this is, obviously, if you damage part of the hull, the area between two of these bulkheads might fill up with water to a certain height, but it will not destabilize the ship to the point where it starts to sink unevenly. So this is it. This is where it is these days, and you can see that it actually has seen better times. There's a group called the Conservancy for the United States that's trying to save the ship and come up with ways of using it, repurposing it, not as a ship. It won't sail again. But, I mean, it's hard to come up with ideas for something 1,000 feet long and 175 feet high that basically is meant to float in water, 100 feet wide due to the limitations of the Panama Canal. That was a requirement pushed on the creation of the ship in the beginning, because it was designed not only as a passenger liner, but just in case as a troop carrier across the Pacific, which is where the trouble seemed to be brewing. Anyway, just a couple of images from I've made 2 or 3 trips now to the ship. Up the radar mast, the whole upper section from the deck, the main deck, the promenade deck, where the hull stops, basically. Everything above that is built of aluminum, so it has a relatively small weight. It doesn't have much strength compared to the steel hull, but it significantly changes the way this ship works in the water. That's something I need to get across. This is the surface of the deck now. That's rust. This is the funnel. This is inside one of those 2 funnels, and you can see it's just basically this vast sculptural form in a very small portion of which the uptakes from the boiler rooms pass and get rid of their soot and stuff like that. This is a little hard to read, this little drawing on the right hand, up there at the moment. But this is more or less what it looks like inside. It's pitch black. There were no lights at the moment. There's no electricity in the ship. So what made it tricky was trying to sort of find your way around. What I found was the digital camera, in my case, was fantastic because it would illuminate the whole space for a split second. And only when you got sort of away from the ship and had a chance to really look at these images did you know what you'd seen. The idea of drawing those photographs is really important for me, and I'll give you some examples of that. Photographs record a lot of stuff, but they don't actually help you see it. And unfortunately, I think for me, what is often the case, get back to the studio with these photographs, and I have so many questions about what's in the photographs that I can't answer. I'm not going back there. So drawing from photographs is really key, and figuring out how to do it. I don't just mean copying the photograph. I mean interrogating the photograph. And finding other information that can help you answer those questions as you start to draw it. The thing is, you won't ask the questions unless you begin to really investigate the photograph, and one great way of doing that is through drawing. These are photographs taken at the time, 1950, 51, of the construction of the ship, and these are often with the perspective and the distortion really difficult to read, but I'm sort of trying to sort of get a sense of the depth here and all that sort of stuff. One of the things that I will do with a photograph like this is draw it, but from a different angle. Turn the whole thing slightly, so I have to draw it from the side. As soon as I change the point of view in making a drawing, I can approach the subject matter in a different way because I start asking questions about, well, what is there? What's behind that? What is that tube connected to? No one angle is going to give me all that information, but the act of drawing it, of transferring it, through this process of inquisition, will encourage me to sort of fill in the missing pieces. There is the sister ship, the America. This big thing in the foreground, that's the dry dock in which the SS United States is being built. And it will fill the dry dock something like this. I mean, it doesn't look like a particularly handsome form, but when you see this thing in 3 dimensions and realize how the curves have been perfected, you realize why it could travel at the speed it could, given the weight reduction thanks to the aluminum and the incredibly powerful engines that ran this thing. Basically, destroyer-powered, battleship-powered engines meant to go fast. The story begins, in a way, in 1894, when we get to the end of an evolution of steamships. And William Francis Gibbs, who designed the SS United States, commits himself after watching the SS St. Louis launched. He's a big fan of Brunel. Who isn't? Who in engineering is not a big fan of Brunel? I mean, an extraordinary guy who, I think one of the things I admire most about Brunel is that he was always willing to learn from somebody else. This is a drawing that shows the sort of dismantled Great Eastern, you get a sense of the amount of space being devoted to the power source and so on, to run the paddle wheels. This is a 650-foot long ship, something like that. It's got a propeller at one end and 2 paddle wheels, and it's still got 6 masts, just in case technology isn't entirely reliable. Gibbs's ship, which he designs when he's about 22, 23, is going to be, in his mind, the fastest, longest ship in the world. This is his dream. It's made possible in part because of work done in the early 19th century to improve steam engines, which go back to 1700. And so here's a little drawing, a set of sketches, basically. They're not pretty, but there's a thinking process, I hope, that you sort of recognize here, as of jumping from one thing to another. In the upper left-hand corner, you have the old steam engine, the kind of thing that would have been used to work a pump to drain water from mines. So you've got a chimney from the boiler, from the furnace. You've got the boiler in purple on top of the furnace. And you've got the piston on the right-hand side, which is going to pull a lever, which is going to work a pump and drain the mine. Okay, well, you can try to put something like that on wheels if you have this idea suddenly for something a little more mobile. This is not a steam engine that's meant to go anywhere. It's 3 stories tall. But the arrangement of those very pieces, the sort of reduction of the things that provide the work necessary to operate something is unchanged. I mean, I just simply bent the chimney in that U-shaped fold, ran it through a boiler of water. So there's a firebox in there, which is creating heat. That heat is moved through that big chimney, which is folded, and then out the top, and so on. Now you've got something small enough to stick on wheels. You can connect the piston to the steam that's being produced at the top of the boiler to keep the piston warmer, so you don't have to keep reheating the piston. You can bury it partly in the boiler so that it's benefiting from the heat indirectly. Anyway, you end up with something that can actually run on tracks. It's still heavy, so you do need tracks. You can't just run it down the road very successfully. And eventually, you will take out that U-shaped thing that leads to the chimney, and you will replace it with lots of small pipes so that a much larger surface area is being formed between the heat traveling inside the pipes and the water around the pipes. So you get a much more efficient use of your fuel. So once you've got pistons working with steam, you can connect them with cranks to a drive shaft, which will lead to a propeller, or one that sort of crosses the ship that leads to the two paddle wheels if you're still using paddle wheels. The problem with paddle wheels, of course, is that as the ship is moving through the sea, it's not necessarily moving steadily or in a more horizontal way. It's the paddle wheels are tending to lift out as the ship rocks, so you're not getting a very even distribution. Now, Gibbs, like Brunel, learned from other people, and he had a chance to work on this enormous German ship that was seized, actually, during World War I, used as a troop ship, and then after the war was converted back into a luxury liner, but now it was an American luxury liner as opposed to the German luxury liner that it had begun its life as. He's got 30 years of basically learning from all these extraordinary opportunities he had, but his dream remains to build this fastest, longest steamship in the world. He works for the Navy, he and his brother, and they actually are responsible for the overseeing and creation of something like 70% of the Navy, of naval and merchant vessels during the war. So they become very successful. William Francis Gibbs becomes the sort of preeminent American naval architect who never studied it. He actually went to Columbia to learn real estate law. Now, you may not see the relationship between those things. I certainly don't. But nevertheless, he did it because he promised his father. He said, I'll do it for a year, hated it, and went back to designing his big ship. And had the extraordinary success of being able to take advantage of every opportunity that came his way. What kind of a drawing do you make to sort of suggest this? Well, I don't know whether he's going to be looking into a tank filled with all his creations as if it was this, extraordinary bathtub experience, or whether it's a test tank in which the hulls were literally tested to improve their workings. His brother, Frederick, primarily is concerned with the adding machine and keeping track of expenses. And the money that came in was obviously considerable. He is very successful even then when the Normandy comes into New York. And this is a page of sketches that is supposed to get across the idea of this fantastic, streamlined, spectacular ship, also won the Blue Ribbon for a couple of years, and had these huge, gigantic public spaces like the biggest hotels and so on and so forth, but on board this ship. So it was that kind of experience. Meanwhile, he and his cohort, another engineer from the firm, snuck down into the engine room, which was all electric motors that made the Normandy a unique ship. I'm playing with possibilities. This is the Queen Mary. I'm not sure what ships to show here yet, but I plunk these things down. The sketches are rough. They're recognizable because I've drawn them enough times. The one thing you will find about drawing that I find, for me personally, useful is eventually you no longer need the subject matter in front of you. You don't need references. You draw things so well and so often, not so well, so often that you can continue to draw it without any backup. And that's when you really start to think about the elements. You're not being distracted by the look of something. You're being concerned more with what it does and what it does in relation to other things. In this case, it's just like shapes related to shapes and so on. The first thing you need to do if you're going to build a United States is get a dry dock ready, which means you have to empty it. And you're basically floating this big wall over to the front of this bathtub, which only has 3 sides. You push the wall into place. You fill it with water so that it drops seals the end of the bathtub, especially when you take the water from the bathtub. When you suck it dry, the river water on the outside of the wall, of course, is pushing it against the end of the bathtub, which creates a really tight seal. So you end up with this space, which then you can lay the scaffolding in. Again, these are rough sketches. They've been drawn many, many times. I don't know whether any of these will make it into the finished book, but one of my favorite photographs is this one. Gibbs was paranoid about fire in his ships, so no wood. He tried to convince Steinway to build aluminum pianos for the ballroom and the first-class dining room and so on and so forth. Steinway refused, but what he did do was fireproof the wood and then set a piano on fire to demonstrate for Gibbs that it wasn't going to go up in flame, create a serious problem. The irony is, everything around the ship during its construction is made of wood, with the exception of the cranes. That incredible scaffolding, the cradles that support the hull as it's being constructed, the block down the center that supports the keel. The keel itself begins as this sub-assembly. The other thing about the ship is that it was produced basically in lots and lots of pre-assembled pieces. So it could be actually put together fairly quickly. It's ironic to think of this beautifully streamlined form being made primarily out of flat pieces of steel, maybe an inch thick, maybe a little more, maybe a little less. Just cut into shapes and then sort of stuck together as you might make a model with a glue gun and foam core. The shapes you can create are really quite beautiful, but the structure inside it is very, very basic. Outer hull at the base. And so now choosing points of view. When you make a drawing and you're trying to explain something to someone else, not only am I synthesizing the information I hope I have learned by creating the double hull shape, the big U shape, so we have an inner shell and an outer shell, I'm also trying to figure out how to get you involved in this, how to make you part of this process, how to let you be a worker for a few pages, as if you were there with your welding torch or your riveting equipment. Both were being used. And watching this thing grow around you, it's the point of view, the use of perspective. These are all important things. Sometimes you need to get away and use something perhaps a little bit more conventional and, frankly, less interesting. A more isometric view, as you see here. But these, you begin to see now the bulkheads, these parallel walls. They're about 40 feet apart, running from one end to the other. And this is the biggest safety feature. First class passengers never had to go through a doorway in the bulkhead, which means wherever their decks and cabins started, the bulkheads ended. But they were far enough up and away from the water that it wouldn't have been a serious problem unless something really catastrophic happened. We were not first-class passengers, just in case you're wondering. Planks, the planking on the exterior of the ship, these are planks that are sort of 8 feet high, 12 to 20 feet long, an inch thick steel, and these are, in the center of the ship, they are riveted, and as you get towards the end of the ship, they're welded. So the surface becomes smoother, so it can cut through the water with a little less resistance. The back of the ship, this is like trying to understand one of these photographs where the perspective is a little disconcerting. It's tricky to sort of figure out. That's the keel at the bottom that's beginning to rise up now towards the rudder. And you've got those tunnels on the sides, and those tunnels will carry the propeller shafts. The two outer ones carry those shafts 400 feet from the main engine room. But you get this extraordinarily beautiful sort of sculptural projection on the side of the hull at the back. This is how it's conveyed in official language, which is almost incomprehensible to any but the engineers and builders working on the project. So what I did was take this plan, print it in black and white, cut each of those silhouettes out, and then stick them together on a cross-section of the hull at the back. And you begin to see in model form how you translate from a drawing. I think building models is really important. And I think building even the most basic, simple, taped together little things can really help you bridge that gap from two-dimensional exploration, questioning, that exercise, into something three-dimensional. And again, it's not about being pretty. It's about, you can only go so far in your drawing in understanding what's actually going on three-dimensionally. At some point, you need to mess with the real thing. And I think the more quickly you can make that leap from drawing to three-dimensional model, the better. You're building this body of information, and these two means of exploring the problem. You're figuring out whether or not you're asking the right questions, is what it comes down to. So whichever of those things you find the most useful, you go for it. This is what it looks like. The actual finished thing looks like this. Now, there are a number of videos available of aspects of the ship under construction, and you see something like this, which might be a little hard. It's impossible, actually, not hard, for you to read. This one's equally difficult, but this is the end. This is the stern tube. This is the last piece of those 4 shafts that come out where you break through the hull in order to have propellers. So drawing from photographs, drawing from video, drawing from photographs in like the Berkeley Engineering Library when I was doing a chapter on bridge building, I began printing out the photographs from the Berkeley Engineering Library, and I realized that the quality was, when it was printed out, was still not good enough to answer all my questions. It could never possibly. So that's when I actually started just looking at the computer screen and making my drawings and asking questions of the image in front of me that were necessary, that would be necessary for me to fully understand about this process. Here's a big casting, welded together in a number of pieces. I'm sure nobody's going to cast anything quite like this, but this is the piece that sits at the end of the keel, and it supports the weight of the rudder, basically. And you can see in cross-section, that dark blue area is that cast piece I just showed you. And in this photograph, we go back, and you can see the rudder in place now. You can see the relationship between... You can see how complicated the back of this hull is, but it has to be. This is the part that's doing the work. The other end is what's pushing through the water. Now, I said they built this thing in a dry dock. They almost built it in a dry dock. The dry dock was, I don't know, maybe 40 feet too short for the ship. But fortunately, where the ship projects, both at the bow and the stern, it was high enough up that it could stick out over the ends of the bathtub. So this is an entirely pre-assembled stern shape. This is the last piece of the ship at the stern end to be put into place. It was built next to the ship and then lifted into place. At some point, you have to start getting the equipment downstairs, and you want to do that before you've covered much of the area with decking. And I need to find a way of suggesting that process just to remind you that you could end up with one of those horrible experiences where you design something for a place and you only realize after the fact that it's 3 feet too large or something like that, and you can't get it in or out. Well, that's tricky with boilers and turbines and reduction gear assemblies and all that sort of stuff, because those things are heavy. Here are 2 of the boilers. There are 8 altogether, 4 for the outer set of propellers and 4 for the inner set of propellers. Now, the system. This is another reason why drawing is so helpful and can happen quickly. You can't really tell what's going on, so I threw some color in. But you can see the boiler in the sort of center, that sort of orangey thing. It's not about making a boiler that looks like a boiler. It's about locating an activity and connecting it to, in this case, the high-pressure turbine, which jumps to the low-pressure turbine, which goes to the reduction gears, which turns the shaft eventually at the right speed. If the shaft turns too quickly, the propeller turns too quickly, you're just going to bubble up the water and not go anywhere. And then you've got oil coming in, and you've got the whole water system, the condenser that takes the used steam, if you will, from the low-pressure turbine, turns it back into water, feeds it back to the deaeration tank where it meets more water, and goes back into the boiler and begins the whole process again. So you've got all these overlapping systems. And part of the reason for a drawing like this, although it's not been carried to its fullest extent, is that I get to see what those systems are. So that when I start drawing the ship in different ways, I have a clearer sense of what's important. That yellow thing is basically just to sort of hint at, symbolize the connection between the bridge in the upper right-hand corner and the engine room. Similar equipment. So the same thing happens on the bridge. If something happens on the bridge, it also happens in the boiler room. The guys know what to do. The boiler room looked like this in 1950, 52. It looks like this now. It was pitch black when I was in there. This is the camera. This is the flash of the camera. Suddenly, this whole room comes alive. I'm not averse to, this is so complicated with all its pipes and things, I'm not averse to using the drawing process here in a very, very sort of fundamental way, tracing the photograph and editing it. That's another thing that you'll do with drawing. When you start making drawings of things, you're really becoming an editor of information. You don't have to draw it all. You have to draw what matters. You decide what matters. That comes from asking questions about the thing you're confronting. That's just turbine to reduction gear. Seeing what the layout of this all is at some point, back to an isometric perhaps. I don't think I would use an isometric like this in the book. But it really helps me to sort of get a sense of the relationship, spatial relationship. Now, this is like 10 steps further along from what I would think that mostly you guys would use drawings for. This is, the thinking process hasn't stopped, but now it's becoming encumbered by other things. This, I have to know that this will fit in this 100-foot wide space, 50 feet deep, whatever it is, and 3 decks high. So this is exactly what you don't do. But this is what I would do, again, to get the sort of scale of things down and to get the system down, just a cross-section right through the entire power plant, basically from oil all the way to propeller shaft. This is how I would much rather work, because not only does it's a little messy, it's still messy, but you can follow, if you're careful, the traveling steam from the steam pipe in the boiler to the turbines. You can see the condenser underneath it. You can see how the water... This is my favorite part of this whole thing. This tube that actually comes from the condenser right through the hull, facing forward, so that as the ship moves forward, water is forced up that pipe, seawater, goes through all the small pipes, which I showed you earlier, except they were carrying hot air, hot gas. This is carrying cold water to condense the steam that's falling around it. And then it gets dumped out back into the ocean. But it's just so wonderfully pragmatic. It's like they made it up during a trip because they were having problems condensing enough steam. I mean, it's beautifully simple. But most of this has a kind of simplicity to it and an elegance that makes it all accessible. There's nothing here so complicated that it sort of falls into the realm of the abstract. I mean, no computers used in designing the ship. Radar, yes, but even that, if you start to think of bouncing, sort of electromagnetic waves off something and recording the time necessary for this thing to come back, and therefore figuring out how far you are from something you want to avoid. The propeller shafts, what's indicated in this photograph is what I showed you from the outside, which was the shape of that thing projecting from the side of the hull through which the propeller shaft goes. Now you can see it from the inside beginning to bulge out. It's this growth that slowly bursts out the end of this thing to support one of these. Now, these propellers are at the Mariners Museum in Virginia. I don't recommend a trip there unless you have other reasons to be down there, but it is terrific to see this thing. And those are like Phillips head screws. It makes me wonder, the guy with the screwdriver must have been enormous, because those things are pretty impressive, these beautiful bronze sculptural things. Now the front, how long have I been working on this book? The bow of this ship is assembled in pieces. And, the two things about the bow that are really important. The first, of course, is its overall shape, so that it can move through the water in the most efficient way possible. Secondly, its strength, because this may be the thing that hits something first. So there's a need to pre-assemble these parts. And there are some photographs available, and I sort of worked with these now. That thing is going to get welded on top, that piece. And then the whole thing will be covered in steel plate. You can see it's already in steel plate on the left and top left. Then they cut it in half because it's too big a thing to move. And then they turn half of it upside down because it was built upside down. It's easier to work with molten steel if it's not dripping on your head. So they have a tendency to build things upside down because it's easier for that. It's safer. But this is one half of that thing I just showed you, now being lowered into the dry dock, and it becomes the sort of the beginning of the whole bow structure. And then you can start to pile things on top of it. That's sort of what it looks like in this little transparent view here. I mean, that's more or less where it is, but the scale is completely wacky. That's too big. It's a smaller part of it, but it's a key part of it. Anyway, it took me a long time to figure out, comparing photographs and the cross-sections, where things actually were. So this little sequence here, drawing on the photographs, why not? Once you've got enough information in your head, you can begin to leave the photograph and start to figure out what the puzzle is. And it is a puzzle. And I don't mind presenting it as a puzzle. And in fact, I think one of the images may very well have all these pieces lying side by side, and not necessarily in the order in which they will be installed. Although that would be counterintuitive to the organization that was actually used at the shipyard. They would have had things exactly in the right place. But I think it's, again, this is sort of connecting people, younger readers often, to information that I want them to be excited about, at least in part, as much as possible, before they get the sort of payoff of seeing a finished ship. Inside the anchor room, these things won't mean anything to you. They're all rust-covered and whatnot, but these tubes that sort of lead from an anchor locker, these big spaces inside the bow of the ship where the chains are dumped and then pulled out through this careful system and fastened to anchors that are hung from the side of the ship, and you want them being moved into these spaces in such a way as to not rip the surface of the hull, rip the paint off, and so on. So anyway, what else do I want to show you here? Oh, I guess I'll lead you to the big. So what you've seen, what you will have seen through all these sketches and bits and pieces, is leading up to an image of the total ship. But in the book, there will not have been an image of the total ship yet. You will only know how pieces of it are built and how pieces go together and how some pieces have to do with moving the ship through water and how other pieces have to do with maintaining the structural integrity of this thing, given the forces that are working against it as it plows through the North Atlantic. So I wanted some kind of concluding image. And, you start with little things. You start with little sketches. And you think, okay, maybe people seem to, especially, there are certain kids who really love looking at cross-sections of things. And you can do a cross-section. You can do a straightforward cross-section and put little people in each of the rooms and so on and so forth, and that may work. But I want something that's got some life to it, because this is not a cross-section of a dead, static ship. This is a cross-section of a ship at sea when everything's going on. So you decide through your sketches how far you can push the manipulation of this information so that you don't lose the sense of organization of the structure of the ship, but at the same time you capture the vitality of this thing as an object connected to the lives of people, each with different responsibilities, needs, and so on and so forth. I thought maybe just peel the wall off at one point. As you can see here, I literally just take the steel and pull it away from the ship, revealing what's up against the outside. But I don't want to be limited just to the cabins and spaces that actually hit the outside of the ship. So, but these kinds of sketches, this is basically what I do all the time. Constantly jumping from one point of view to another to see if I fully understand what it is I'm trying to say, what it is I'm trying to do. Do I understand the information? So I think, okay, I've got the information. Let me just take another shot at just the bow end of the ship. And so I start with that, and it's too short. It looks like it's been scrunched up against the pier. So I cut it up and Xerox it, cut it up, paste it down, use it as the sort of skeleton of a larger drawing, the next drawing, at which I'm really trying to make sure I have the right number of decks now. What happens as you do these drawings over and over again is you start to get a little bit sloppy. And so you have, every once in a while you have to stop yourself. But that's the great thing. These are not, for the most part, these are starting to get to be larger drawings, but most of the drawings I've shown you, and the drawings on which these are based, tend to be really small and quickly drawn and dispensable. So it grows and it grows and it grows. So eventually you get to something like this where you can begin to reveal the internal structure of the ship. You begin to suggest the activities. Some of the cabins and rooms on the outside are shown. The hospital will be shown. The morgue will be shown. The two refrigeration units, one labeled eastbound meat, the other labeled westbound meat. We were in a cabin directly over westbound meat, which I thought was incredibly appropriate. Not that I knew it at the time, but having read that. And then, of course, the engine rooms, the boiler room particularly, all the way up through the funnel, the engine room right behind it, the propeller shafts right behind that. All this is to finally get me to this kind of an image, which, even though this is really rough and sketchy and so on, will have enough kind of life to it, I hope, enough useful distortion to engage the reader and make it look like less of a less of a diagram. But it has to have diagrammatic qualities. And I think that when you're drawing, you probably feel that much of the reason for even bothering to pick up that pencil as you're having this conversation with somebody or as you're just sitting by yourself trying to work something out is to sort of diagram the information in a way that makes sense to you. Okay, so the payoff. This is a dummy of the book, which will have the story in it, of course, like 64 pages worth of story with the various aspects of the ship, power, structure, life on board, and so on. But what I wanted was to create a book that, let me see if I can do this. The whole point is when you get to the end of this thing, we should do that. So I want you to have a book that is like 8.5 by 11, but that has this 7-foot area run. And this, to me, this is the payoff for having put up with all this technical information and so on and so forth, which I will try to make as interesting as possible, so that you then have the, hopefully the satisfaction of lying on the floor with this book, because there's no other way to read it, and sort of transporting yourself, getting yourself into it. And I think it's big enough to do that. It's so much of this information could be conveyed through the computer, could be conveyed digitally. Those of us still in the old world of bookmaking have got to find ways that aren't gimmicky, but that allow the reader, user, to do something that the computer can't do. So anyway, that's the sort of tactile part of this. Now, I was thinking that you're going to be you're working from ideas, you're working with projects that have to do with mobility and portability. And I couldn't really anticipate what those things were going to be. I saw that somebody has suggested ski boots that don't make you feel like such a klutz, presumably, when you're walking around between skiing sessions. It's not so much of the plod thing. So I don't know what you do. It's an interesting problem. I began to wonder, well, what is the issue here? Is it the fact that these things don't move the way your foot does? There's no aspect of this thing. Do you create something inside this solid, unchangeable boot that actually feels like a normal shoe under normal circumstances? Is that possible without this thing becoming even larger? Do you decide to articulate a ski boot? Is it possible? I don't ski, so I have really no clue of what I'm talking about. But is there any articulation of a ski boot? Or is it primarily meant to be static, structurally solid, unmoving, inflexible? I don't know. But those are the kinds of questions that I would be asking if I was sort of drawn into a project like this. What are the important issues? There's what the client wants, but there's also what do I need to know to even begin to be in a position of having some kind of opportunity to offer some insight here and think about what it might look like or how it might need to be manufactured. What changes would there need to be? Does it come down to materials? Does it come down to sort of structural organization, to breaking something down into a number of pieces where there was just one? What was the other one? The other portability, there was some other suggestion that somebody had.
You can
Yeah, you can.
What you're working on at the moment? Why don't you?
Yeah, what do you? I mean, have you? This is. I don't know how early this is in the year, and whether you've actually figured out what your thing is, but that you're trying to do. But that list of questions that can be spurred on by, released, freed by the act of drawing, is obviously the step you're up to now. And drawing will simply allow you at this stage of the game to organize that information in certain ways, so you'll begin to understand, sort of like Venn diagram kind of thing, where you begin to see how collections of information and facts naturally group together, and where they overlap other things, and where you see an opportunity for something that might be unique, might be different, might be that the one thing that separates what you're creating from all the other things that are being created for a similar purpose. But no one saw that one little thing, that one little opportunity. And I think it's in those often overlooked things that we take for granted that possibilities are missed when you start designing things. You want to keep it as open and as free as possible for as long as possible. Because once you have figured out, and you really are, I think, convinced about this is the problem that we're trying to solve, you are already 70% toward the finished product. The danger is, of course, minimizing the importance of isolating the problem and of really being clear about what you're after and trying to go right to the product too soon. That's when I think you lose. And I mean, I studied architecture, and it wasn't until halfway through architecture school that I realized that these 3 or 4 page so-called problems that we were given every 6 weeks weren't really the problems. They were the starting point. Our responsibility was to figure out what the problems were based on this list of requirements. And there are two quite different things. And in trying to isolate and clarify the problem, which you are designing, you are creating the finished solution. You're well on your way to creating the finished solution. So I don't know whether you have questions or... Yes, fire.
Can I ask you a question kind of from the point of view of someone who doesn't have much practice or artistic skill?
Right.
How do you deal with, so if you studied architecture, so you have a lot of time to deal with perspective, but if you're not used to working with perspective, how do you kind of take that out of the equation while keeping the drawing cogent?
Well, it's hard. I mean, what you really want is, do you take perspective out of the equation? Actually, in many cases, it won't be necessary to involve perspective so much, because you won't be talking about things that deal with really large space. You might be, in which case you better learn perspective, because it's really not hard. But if it's not necessary, you're really talking about finding ways, often crude ways. Don't worry about artistic, I can't draw a straight line kind of thing. You just want to figure out how to get your hand and eye moving in response to things that are going on in your brain. It's not about making art. It is, it's reduce the subject matter to simple shapes, objects. Maybe they're flat to start with. Then maybe you give them some depth, like in isometric depth, not even in perspective depth. So, that's just sort of exercises. It would benefit you, I think, to overcome a little bit of that inhibition at first by taking every opportunity you have to do some drawing. I don't mean even half an hour. I mean 10 minutes. Sitting, drinking your coffee, and you draw the cup. And then you draw the utensil on the table next to the cup. And you begin to start to just do it. It's like, it's just another form of exercise. But it's exercise that can sharpen your observational skills and free you from some of the nervousness. I mean, drawing really complicated things is hard if you try to do it all at once. But what you will find is, like with any complex problem, you're breaking these ideas down into smaller and smaller pieces until you can actually figure them out. So draw little things. Draw really simplified versions of what it is you're after. Don't ever think about the finished product. Is this going to be clear to anybody? If it's going to be clear to somebody, that's another level of demand. I would say, is it helping you be clear to yourself about what's important? I know I'm being ambiguous in my response to your question, but I don't know how to do it any other way. It's certainly not about developing highfalutin drawing skills to produce beautiful things. If that is a requirement that you eventually decide is necessary because it will be the best way of sharing what you've come up with a particular audience, then find somebody who will do it at that level if you can't get yourself to that level. But who's going to convey the information to that person, to that sort of official artist type of person, the renderer? You are. You created this thing, and one of the best ways for you to talk to this person might very well be through your own sketches and drawings. He, she will understand. And the more you do it, the more comfortable this gets. Just like making lists of things and sort of summarizing information in short sentences and so on, making little sketches, having all this stuff, filled pages, is all part of a journey that will bring you to a place of some kind of confidence that you've created something that really does hold together, really makes sense. And as I said earlier, don't overlook the notion of that jump to a three-dimensional model as opposed to a two-dimensional model, whatever that is. You just need simple materials, just some cardboard and some tape and whatever. But it's amazing. Xerox on cardboard, cut up your pieces and see if they stick together the way you thought they might. And then from that you can draw. Again, you can actually draw from the object that you've just built, and you can start to refine it as a drawing rather than worrying about refining it in 3 dimensions, because that is a little bit more time consuming. It's a matter of keeping the exercise alive. So 10 minutes a day in a sketchbook. Draw. When you're at classes like this, get your sketchbooks out and just start drawing. And then you will actually, really get something out of it. All right. I think we're done.
Thank you very much.
Oh, good. Thanks. I hope, I never know. I always end up dwelling on my own stuff because it's what I know. But I always wonder whether they've extracted enough to be useful to them, or just caught a spark of something that they might want to try, which is what I would hope for. A spark. Good. Yeah. I think it's really important. I make those models, as you saw, because I just can no longer I can't believe the drawings anymore, because I can distort things in drawings and they look right, but is it really right? Is it really the right scale and so on? So the models become very important, and especially these guys are making real things, so the model is crucial. Good. Yeah. No, I think it's great. You're really pushing them, and they have to move fairly fast and efficiently on this. And if they can just get some comfort with the sketching, then it's just another tool in their arsenal. It's another tool for them to work with and so on. So, and that was a question I didn't, I'm not all surprised. But how do we do it? Well, that's another set of exercises and so on and so forth. It's just becoming comfortable.
Is there something that you would recommend if the student has a reading in addition to your books?
I could. There are some sketchbooks out there, but I think it's more important to do it.
Yeah.
I would say get some little things that you could take apart and draw them, and then draw them in a way that we would know how to put them back together, and think about it, and then draw it from this side, and draw it from underneath, and just a set of exercises like that would be, I think, really terrific for those who wanted to develop some kind of more confidence in that.
Maybe I should read that as an assignment.
Well, one of the things I was going to show, but I didn't, was the this is from what was the light switch? I went to Dan and Witt's and bought a light switch, and I took it apart, and I did not know that there was a spring inside the light switch. I mean, you know it, you sort of know it, but then because you can feel it when you flick it. But why the spring? And the more I read and thought about it, the spring obviously is to make that on-off happen as quickly as possible, so that you don't have a spark jumping across from one electrode to another electrode. It's great if you're welding, but it's not so great if you're welding inside your wall. So, but it was because of taking this apart and drawing it that I, even thought about, okay, what was the purpose of the spring? And then it took me back to, using arc lights and things of that nature, where you want the longest spark you can get, continuous arc, to be able to produce light, even if it's not very good light. So drawing opens doors. It's a really, it gives you more ability to communicate to somebody else. It gives you more of an opportunity to understand bits and pieces of the world around you, so that when you are charged with coming up with something that will have some purpose, it makes sense. You've sort of come at it from all kinds of different sides. And drawing, I think, is a great way of also synthesizing information from lots of different places, from a conversation with somebody, from an encyclopedia, from online, from whatever. Anyway, I never drew, but never got to that.
This has been truly wonderful. And I see there's one student who has a question. Yeah?
So I didn't get your email about the art gallery until today.
Okay.
The art thing. Is it okay for us to?
Sure, absolutely. I was not another email, but there should.
Yeah, sorry, I didn't get into this morning. So.
I don't know what it is. It's been trouble.
Yeah, but I'll send you an email. Thank you, though.
We'll see you tonight. We're so glad it worked out. I'm glad you could come. That's.
Oh, I'm glad you're asking. It was fun to do. And,
Would you be interested in doing it? Yeah.